Okay, this is Similar Triangles application problems from in class on Thursday, February 7th. So number one, a tree 24 feet tall casts a shadow 12 feet long. Brad is 6 feet tall. How long is Brad's shadow? So the first thing we want to do on these is draw the problem out. So the first thing we have is a tree. It's 24 feet tall. Okay, so this is my tree. 24 feet tall. And it casts a shadow that is 12 feet long. So if we have a sun in the sky, okay, and here comes a light ray from the sun, okay, it's going to hit the ground here. That means the tree's shadow is going to be this part along the ground, and it is 12 feet long. So here's the ground. Sunshine comes down. This is the top right above the tree, comes down, hits the ground, and everything on this side is the shadow. Okay. Then we have Brad. He is 6 feet tall. Okay. We want to know how long is Brad's shadow going to be. Okay. Well, if we assume that they're casting a shadow at the same time and generally the same location, we can say that the angle where the light's coming down is going to be at the same angle. Okay, the sun is quite far away, and so any difference between where Brad's standing and where the tree is, as long as they're relatively close to each other, the angle of that sun is going to be very similar. Okay. It might differ by 0.00002 degrees or something like that, but we can assume it's the same angle for our purposes. Okay, and then we have two right angles. Okay, assuming the tree and Brad are both standing upright, we have two right angles. Therefore, we have two pairs of corresponding angles that are congruent. Since we have two pairs of corresponding angles that are congruent, we know by angle-angle similarity that the two triangles are similar. Since the two triangles are similar, we know that the corresponding sides, the ratios of the corresponding sides are going to be equal. The sides are going to be proportional. So we can set up a proportion. So we're trying to find x, which is the length of Brad's shadow. So proportion is going to be 24 and 6. And it's going to be equal to 12 over x. Okay, so 24 is to 6, as 12 is to x. Okay, we're comparing the height of the objects, the tree and Brad, with the length of their shadows. Okay, and we know they're proportional because we know these are similar triangles. Okay, we want to solve the proportion, so we cross multiply. So we're going to get 24x equals 12 times 6. Okay, 12 times 6 is 72. We divide both sides by 24, we get x equals 3. So we have a shadow for Brad of 3 feet. Brad's shadow is 3 feet. Number 2, triangle EFG and QRS are similar. The length of the sides of EFG are 144, 128, and 112. The length of the smallest side of QRS is 280. What is the length of the longest side of QRS? Okay, so start by drawing our triangle. So we have EFG. And we have QRS. The lengths of the sides of EFG are 144, 128, and 112. It doesn't matter where you put them, okay, because it doesn't specify. So this could be 144, this could be 144. As long as you have one side that's 144, one side that's 128, and one side that's 112. Okay. It next says the length of the smallest side of QRS is 280. So to find the smallest side of QRS, we have to find the corresponding side in the other triangle that is the smallest. So if we look at EFG, for us, the smallest Number is 112. We've placed the number 112 on the FG, and we could place it anywhere, but we just put it on the FG. So the side on triangle QRS that corresponds with FG is going to be RS. Okay, so that's the shortest side of RS, so that's going to be 280. Okay, this was S down here. 280. Okay, what is the length of the longest side of QRS? So again, the longest side of QRS is also going to be the longest side of EFG. So if we look at EFG, we can look for the longest side. The longest side is 144, that is EF. So the side that corresponds with the longest side of the first triangle, and the second one is going to be QR. So we can put an X, because that's what we're trying to solve for. We're trying to find the value of the longest side, and we know the longest side has to be QR, because in the other triangle it's EF, and those are corresponding sides of similar triangles. Our triangles are similar. Now we can set up a proportion. So 144 is to X. That's one pair of corresponding sides. Then we're going to have 112 over 280. And it's another pair of corresponding sides. Okay, so those ratios should be equal because the triangles are similar. So we can cross multiply. So we're going to get 112x equals 144 times 280. Okay, 144 times 280, I believe, if I remember correctly, was 40,320. And when we divided by 112, we got x equals 360. So the length of the longest side of QRS is going to be equal to 360. Number 3. A 40-foot. We can zoom in a little bit to get us a little bit more room here. A 40-foot flagpole casts a 25-foot shadow. Find the shadow cast by a nearby building 200 feet tall. So here we have a flagpole with a flag on it. Okay. Should be a straight flagpole that goes straight up and down. Okay. And it casts a 25-foot shadow. So again, we have the sunshine. The light from the sun comes down, hits the flagpole, and casts a shadow. So the flagpole is 40 feet tall, and it casts a 25-foot shadow. So the shadow is going to be 25 feet. The nearby building is 200 feet tall. So 200 feet. Okay, and again, it's going to come down at the same angle. The sunshine is going to come down at the same angle, and we want to find the shadow cast by that building. So the angle of the sun is still going to be the same when they're nearby objects. Sorry, we can't read the question here. Okay, when they're nearby objects, we're going to have right angles. The building's going to be assumed to go up at a right angle. The flag is going to be assumed to be up at a right angle. So we have angle-angle similarity. Since we have angle-angle similarity, we know the triangles are similar. Since the triangles are similar, we know the sides are proportional. Since the sides are proportional, we can set up ratios comparing the corresponding sides. So 40 is going to correspond with 200. And 25 is going to correspond with x. Okay. Remember, if the numerator is coming from this triangle, if we're doing 40 over 200, we have to do 25 over x. Okay, if we flip them, we can do 200 over 40 equals x over 25. but we can't mix and match. We can't do 40 over 25 equals x over 200, right? We have to keep it consistent. Okay. Cross multiply, we get 40x. 200 times 25. What is that? 5,000? 50,000? Divide by 40. X is 800 feet. Okay, so the shadow, that's not right. I think it's 125 feet. The shadow cast is going to be 125 feet. Remember our calculator though? 200 times 25 is 5,000. So 125. So the shadow cast is 125 feet. A girl, 160 centimeters tall, stands 360 centimeters from a lamppost at night. Her shadow from the light is 90 centimeters long. How high is the lamppost? So we have a girl. Okay. Happy girl. Okay. She stands 360 centimeters from a lamppost. So she's standing. Okay, we'll make this our lamppost. So she's standing 360 feet from the lamppost. Her shadow, so the lamppost emits light, which is going to cause a shadow on the ground. Okay. And that shadow is 90 centimeters. She was 160 centimeters tall. Okay. How high is the lamp? That's going to be our x. So if I were to draw this again, with just triangles, just lines, we have 160, 90, 360, and x. Okay, and the question is, what's the value of x? So to find the value of x, we can separate this into two separate triangles. So again, we have the small triangle, okay, which is 160 as a height, 90 as a base. Then we have the large triangle, okay, which has x as a height, and the base is 450, right? The base is the entire thing, 450. 360 plus 90 is 450. 90 plus 360 is 450. This whole thing is 450. So all I did here was separate the two triangles. I pulled this one out. So now we have the big triangle here. That's the big triangle. And then we have the small triangle, which is here. Okay. So the lamp is emitting light. Okay. It's going to be coming down at the same angle. So these two angles are the same. And then we have right angles. So we know those triangles are similar by angle. Therefore, we know the sides are proportional. 160 compares to x. And 90 corresponds with 450. Okay. 160 corresponds with x, 90 corresponds with 450. Cross multiply, we get 90x. We get 160 times 450. 160 times 450 is 72,000. So we get 90x equals 72,000. We divide by 90, and that's where we get 800. So it's going to be 800 centimeters. The height of the lamppost is 800 centimeters. Okay. 800 centimeters. So again, the key here was knowing that this is our small triangle. This is our big triangle. The base of this triangle is 450. 90 plus 360. 450. Okay. 5 and 6. A tower cast a shadow 7 meters long. A tower casts a shadow 7 meters long. A vertical stick casts a shadow of 0.6 meters long. If the stick is 1.2 meters, how high is the tower? Okay, so this is like number 2 or number 1 and number 3. So we have a tower. We don't know how high it is, but it casts a shadow. Right? The shadow here's the sun. Okay, it casts a shadow that is 7 meters long. Okay, we don't know how high the tower is. There's also a stick. It casts a shadow of 0.6. And we know this, if the stick is 1.2 meters, how high is the tower? So again, we're assuming the stick is vertical, so it's a right angle. The tower, we're assuming, is a right angle. The sun is coming down at the same angle. Okay, again, you have to think about how far away the sun is, and so if you have two objects right by each other, the angle of that sun is going to be very similar. It might be 0.00001 degree off or something, but for all intents and purposes, it's the same. So we have angle similarity. Since we have angle similarity, we know the sides are proportional, meaning the ratios of the corresponding sides are going to be equal. X is to 1.2. As 7 is to 0.6. X corresponds with 1.2, 7 corresponds with 0.6. Okay, so we get 0.6x equals, what is this, 8.4. Divide by 0.6. We get x equals, I believe, 14 meters. Okay. 1.2 times 7. Yep, and then divide by 0.6, and we get 14. Okay. Triangles IJK and TUV are similar. So here's our triangles, I, J, and K. And then we also have triangle T, U, V. The lengths of the sides of IJK are 40. 50 and 24. The length of the longest side of TUV is 275. What is the perimeter of TUV? All right, so there's two ways we can do this problem. First, well, in both cases, we have to find, we got to put label 275 somewhere on triangle TUV. So the way I labeled my triangle, my longest side is the 50, which is JK. JK is going to correspond with UV. Okay. So if they're similar, which they are, and if JK is the longest side, then UV is going to have to be the longest side. And it tells us the length of the longest side is 275. And this is where we can branch off and do it two different ways. Okay, the first way is we can find UT and TV. We can call them X and Y. We can find each. Then to find the perimeter, we can add X plus Y plus 275. So let's do that. X and 40 are going to correspond, so 40 over X is going to equal 50 over 275. These sides are corresponding, so 50 over 275. Okay, we cross multiply, we get 50X. 40 times 275. So 40, we want to divide by 50. We get X equals 220, so 50X was 11,000 divided by 50. X is 220. Okay, that's not our final answer, but X is 220. Then we need to set up a ratio, a proportion to find Y. So 24 and Y are corresponding. So 24 over Y is going to equal 50 over 275. Cross multiply, 24 times 275 equals 50Y. 24Y, I'm sorry. No, that's right. Yeah. Okay, 24 times 275. 6,600. If we divide both sides by 50, we get 132 equals Y. Okay, so this is 220 and then 132. Then to find the perimeter, we would simply do 220 plus 132 plus 275. So 132 plus 220 plus 275. We get 627. Okay. The other way we could have done this is we could have found the perimeter of the first one. So the perimeter of the first one is, let me rewrite it up here. So we had 40, 24, 50, and then we had 275. Okay, if we find the perimeter here, we do 40 plus 50 is 90. 90 plus 24 is 114. And the perimeter over here, if we call that X or Z or something, called Z. Well, we know since all the sides of the triangles are proportional, that means the ratio of the perimeters is also going to be equal to the ratios of the corresponding sides. Okay, so if the similarity factor is 2/3, the ratio of the two perimeters is going to be 2/3. Okay. So we can compare sides, a ratio of sides to the ratio of perimeters, because those ratios are going to be equal. So the ratios of the sides are going to equal the ratio of the perimeters, because the perimeters are all the sides added together, and all the sides are proportional anyways. So we can include perimeters in our ratios because they're going to be the same. Okay, so 50 over 275 is going to equal 114 to Z. Okay, 50 times Z, 114 to 75. Okay, 114 times 275, 31,350. Divided by 50. We get 627, just like we got done. Okay, either way would work. Either way is perfectly fine. Okay. Number 7, a tree casts with a height of 4 centimeters. Okay. A tree with a height of 4 meters casts a 15-meter long shadow. Okay, so it's either evening or early in the morning, because the shadow is longer than the height. I mean, we're below a 45-degree angle. So a tree with a height of 4 meters casts a shadow. So here's the ground. So it's going to cast a shadow that is 15 meters long on the ground. How high is another tree that casts a shadow? So here's another tree. This will cast a shadow that is 20 meters long. How tall is the other tree? Well, again, we're going to have right angles. Okay, and the sun's coming down at the same angle, so we have another pair of corresponding angles that are congruent. So we are going to have angle-angle similarity telling us that these two triangles are similar. 4 is going to correspond with x, that's the height of our trees. And then the shadows are going to correspond. They're going to be corresponding sides. So 15 over 20. Okay. 4 is to x as 15 is to 20. Cross multiply, we get 15x equals 4 times 20 is 80. Divide by 15. X is going to be 16 over 3, I believe. Sixteen thirds, okay, which is 5.3 repeating. So this tree is 16 and a third meters high. Okay. Triangles CDE and NOP are similar. Okay, so here's triangles CDE, triangles NOP. The perimeter of the smaller triangle is, so the perimeter is 133. The length of two corresponding sides of the triangles are 53 and 212. So it doesn't matter which ones we pick as long as they're corresponding. So I'm just going to do CD and NO. So CD is 53. NO we're going to say is 212. Again, it could be any pair here as long as they're corresponding. What is the perimeter of this one, of NOP? So we're going to call that X. And again, just like with number 6, we can, the second way we did number 6, since we have corresponding sides, the ratio of the corresponding sides is going to equal the ratio of the perimeters, because the perimeters are coming directly from the sides themselves. We're adding the sides up for each of them, and since those sides are proportional, then the ratio comparing the two perimeters is going to be the same as the ratio of the sides, the corresponding sides. So 53 over 212 is going to equal 133 over x. Right? These are corresponding sides. And then when we have CE, then we have the perimeters, 133 over x. Okay, and since we did 53 first, we have to have 133 on the numerator. Cross multiply, we get 53x equals 212 times 133. So 212 times 133. It's going to give us 28,196. 128, 128? 181,000. 28,196. Divide by 53. We get 532. Okay, so the perimeter here is 532. Number 9. Number 9. We're doing that time 29 minutes. Okay. So Lisa began walking up a hill at a spot where the elevation is 0.9 kilometers. So here's a hill. She began at 0.9 kilometers. Okay. After she walked 3 kilometers, so she walked up this hill 3 kilometers. She saw a sign giving the elevation as 0.95. So now she knows that this elevation here is 0.95. Okay. You know this is 0.9. You know she's now at an elevation of 0.95. So how much more has she gone up? Well, she's gone up from 0.9 to 0.95. So she's gone up 0.5 kilometers. So 0.05, I'm sorry, 0.05 kilometers. Okay. How far will she have walked when she reaches an elevation should be an elevation of 1.1 kilometers. Okay. So here again, she starts at 0.9. Okay, if she walks 12 kilometers. Okay, how far? I'm sorry, I'm ahead of the gun. That's not. Okay, that's what we're trying to find. How far will she have walked when she reaches an elevation of 1.1 kilometers? Okay, if she starts at 0.9, how much has she gone up? She's gone up 0.2. She started at 0.9, now she's at 1.1, which means she's gone up from 0.9 to 1.1. So 1.1 minus 0.9 is 0.2. So she's gone up in elevation 0.2 kilometers or we're trying to find how far she walked after she went up 0.2 kilometers to get to an elevation of 1.1 kilometers. Okay. Well, the angle of the hill is going to be the same in both examples, both diagrams, and the elevation is going to be measured at a right angle relative to the center of gravity of the center of mass of the Earth. So we have angle similarity. Since we have angle similarity, we know the triangles are similar. Since the triangle is similar, we know the sides are proportional. So we know the corresponding sides of these triangles, the ratios of the corresponding sides of the triangles are going to be congruent. So 3 is going to compare to x. Okay, and then 0.05 is going to correspond with 0.2. Okay, so we get 0.05x equals 3 times 0.2. This is going to be 0.6. Okay, divide both sides by 0.05. And x is going to be 12 kilometers. So we know this is 12 kilometers. Okay. All right, and it's a similarity factor of 4. This triangle here is 4 times bigger than this one. So 0.05 times 4 is 0.2. 3 times 4 is 12. The foot of a ladder. So foot of the ladder, meaning the base of the ladder, the part that's on the ground, is 1.2 meters from a fence. Okay, so let's just here's the foot of the ladder, and we have a fence. So here's the foot of the ladder. We have a fence that is 1.8 meters high, and we know the foot of the ladder is 1.2 meters away from the foot of the ladder. The fence is 1. So this is our fence right here. Fence. If we can read that. This is our fence. So here's our fence. Okay. 1.2 meters to the foot of the ladder. And our fence is 1.8 meters high. The ladder touches the fence and rests on against a building that is 1.8 meters behind the fence. So on this side, we have 1.8 meters to a building. Okay. It says that the ladder touches the top of the fence. So it's going to be something like this. So here's our building, which is X meters high. Here's our fence. Okay, and this is our ladder. So we have a fence. 1.2 meters from it is the foot of the ladder, meaning the base of the ladder. Okay, the fence is 1.8 meters high. The ladder touches the fence and rests against a building So it touches the fence. That is 1.8 meters behind the fence. The building, here's the building, 1.8 meters behind the fence. Draw a diagram and determine the height of the building reached by the top of the ladder. So how high does the ladder reach? It's going to reach this distance here, which we're going to call x. So we have two triangles. Again, if we need to see them better, we can have this one, which is 1.2 and 1.8. And then our large one, okay, is going to be x and 3.0 meters, right? 1.2 plus 1.8 gives us 3.0 meters. Right, so we have a fence and a building, foot of the ladder. Ladder goes on the fence against the building. Ladder is 1.2 meters from the foot of the ladder is 1.2 meters from the fence. Okay, the height of the fence is 1.8. The building is 1.8 meters behind the fence. So the big triangle is going to be x by, right, so here would be our fence. Right, if I drew a fence in here. So this would be 1.8, this is 1.2, the total is 3. Okay. So 1.8 is to x, as 1.2 is to 3. So cross multiply, 1.2x, 3 times 1.8, it's going to be 4.6, maybe. 5.4 divided by 1.2. We get 4.5, 4.5. And that is in meters. 4.5 meters. So the ladder is going to reach 4.5 meters up the building. Last two, 11 and 12. Okay. 11 and 12. Okay. So a rectangular soccer field is 120 yards long by 64 yards wide. So here is a soccer field. It's a rectangle. So 120 yards long by 64. Okay, what dimensions would a scale drawing of the soccer field be if the field were used drawing? So these are yards. Okay. What dimensions would a scale drawing of the soccer field be if the field? Oh, we already on. If the field were drawn using the scale 1/4 of an inch equals 10 feet. Okay. I don't like the scale very much here. Trying to see if we can make it easier on ourselves. So there are 3 feet in a yard. Okay. So let's convert all of these. Well, 64 doesn't divide by 3. We're just going to have to deal with bad numbers. Okay, so we want to find a new model of our field with using a scale. Okay, where 1/4 of an inch equals 10 feet. Okay. So we have yards. This really isn't a good similarity problem. But okay, so the length is going to be 120 yards. Okay, we know there are 3 feet in 1 yard. Okay, and then we know there are, so they want to know how many units. Okay, so we got to get it in inches and then I don't like this problem. It's not fit, it doesn't fit this is too much. Not what we want to talk about. But 3 feet in a yard, and then we have 12 inches in 12 inches in 1 foot. Okay. And then trying to think how we want to do this with quadrilaterals instead of just doing a unit conversion. Basically saying every 10 feet. So basically we have to figure out how many feet there are, how many units of 10 feet there are. So okay, so let's find out how many units of 10. So this will convert it to feet. Okay, so we know we're going to have 360 feet. Okay, and then every 10 feet, every 10 feet is going to be a 1/4 inch. So every 40 feet is going to be 1 inch. Not 1 inch of the field, but 1 inch of the model. So every 40 feet is going to be 1 inch of the model. So it's not 1 inch of the field, it's 1 inch of the model. Okay, so then we want to do 360 divided by 40, which is 9. So 9 inches model, not the field. Okay. And then we can do 64. So 64 yards. Okay, 3 feet in 1 yard. Okay, and then for every 10 feet, so for 40 feet, we have 1 inch model. 1 inch in the model. Okay, so 64 times 3 divided by 40 is going to give us 4.8. So our model is going to be 9 inches long and 4.8 inches wide. Okay. Those are the dimensions of the model. Don't worry about that problem. Just skip that one. I'm trying to think if there's a simpler way to do it. It's more relevant to what we're doing other than unit conversion. But I can't think of a way. All right, well, don't worry about number 11. Just skip number 11. But it should be 9 by 10, 4.8. 9 by 4.8 would be the model of the field. If every 1/4 inch of the model equaled 10 feet of the real thing. Okay. In the diagram shown below, we have a metal support brace that's added to stabilize a metal triangle. The brace is parallel to the 18-foot base. So since they're parallel, we have corresponding angles that are congruent. We now have angle similarity. We actually have 3 pairs of corresponding angles that are congruent. So we have angle similarity. So the triangles are similar. Since the triangles are similar, the sides are proportional. So we want to find the length of the base. We're going to call it x. Okay. So our top triangle here is 4 and x. Our bottom triangle is 4 plus 6, which is 10. And our base is 18. So 4 is going to correspond with 10. And x is going to correspond with 18. So we have 10x equals 18 times 4. 10x equals 72 divided by 10. X is going to be equal 7.2 feet. So the metal brace is 7.2 feet. Okay. And that is it. Those are the 12 questions on the application word problems. The other type of application problem you're going to get is the tine with the mirror, but we'll do more examples of that. We've already done a couple, but we'll do more of that